holiday example halkiyin lesser torsion. We have 3 examples. This is the first example. Number 1. Example number 1. Equilibrium torsion. Equilibrium torsion. This is equilibrium torsion. It's required to design this section for torsion. Shear and torsion. The section is 700 millimeters. This is 700 millimeters. The width is 400 millimeters. Our section is work in practice. We have reinforcement, longitudinal reinforcement, 2, 5, 12 millimeter at tops. This design 4, 2, 3, 4, 5. For bending, here we have 5, 25 millimeters. This is for bending, this is also for bending. 5 millimeter. Stirrups is unknown. It's required to design for shear and torsion. For transverse enforcement, يعني shear, longitudinal enforcement, كيفية vista for torsion. كيفية vista for torsion. Applied, we have applied shear في ultimate أكسانة دوسته 5 كيلو نيوتن و applied torque is equal to 5 كيلو نيوتن per meter. FC prime is given. Strength of the concrete 28 megapascal. 28 megapascal. و FY is 420 megapascal. These are given in the problem. These are given in the problem. Yeah. These are given in the problem. أما ultimate these are at D. These are at D. Use the closed stirrups. Use the closed stirrups. D here is equal to, it's a now solution. I go to solution to solve this problem. D, I have D dash, we have D dash from center to here. Akachi, chill, زائدا دا cover, this cover. stirrup كمان there, stirrup كمان there. زائدا 12 over 2 أو إيش كان 12 أكاتا 56 مليم. D is equal to chan from top compression fiber to center of the tensile steel أكاتا حفصت minus cover chill minus stirrups minus 5 استفينج area استفينج over 2 is equal to شصته سيو حفت مليم. D مانزاني D dash مانزاني أولا now equation بيرسمان فيتي. Now check the section for shear. Check the section for shear. Design for shear is required or not? Design for shear is required or not? This is the first. The second, design for shear is required or not? If V ultimate is less than 5 VC over 2, it's not required to design for shear. Now I check this value. VC متنازعاً VC checker. أكاتا 0.17 lambda FC prime BW D is equal to 0.17 lambda is 1 F prime C28 BW. This is BW, width of the beam, times D. We found D شصته سيحف. Then we found VC. We found VC is equal to دوسته بستنو 0.4 دوسته بستنو 0.4 كيلو نيوتن. Now phi VC over 2 أكاتشن phi 0.75 in shear. VC أكاتا دوسته بستنو 0.4 over 2 for shear over 2 أكابشن over 2 أكاتا 86 كيلو نيوتن. This is resisting for shear. اگر كمتر بو في ultimate لما كمتر بو required for torsion ناوي بس اگر زيادتر بي اس بي اتي اذا في ultimate شنو كانت في ultimate في ultimate is equal to given 250 كيلو نيوتن 250 كيلو نيوتن اذا this is more than this اذا design for shear is required is needed PSPAT. Oh, this is the first. Second, check the section for torsion. For torsion PSPAT yana for torsion. Check the section for torsion. زانين for torsion evet يعني إذا if T ultimate is less than or equal to phi T crack over 4 at that time is not required. T crack now I try to T crack is equal to 0.33 lambda FC prime ICP square over PCP. Okay, ICP checkout. I have this section. This is X naught كيكسانة شوارصت و this is Y naught كيكسانة بحفصة. إذن ICP is equal to كان سيزي يكسانة شوارصت times حفصة أكاتا 68,000 أكاتا 280,000 طبعي بساتر مليمتر سكر PCP شي أكاتا parameter closed parameter يعني بيالين circumference مستشي اوكي يكسانا X naught plus Y naught summation X naught شوارصت زائدا Y naught حفصت times 2 شوارصت حفصت 400 700 إذا times 2 أكسانا يانزا هزاكا 2200 مليمتر PCP مانج closed parameter مانج زاني PCP مانج زاني 2200. Now I can find the T crack. T crack is equal to what? أكاتا 0.33 times lambda is 1 times F prime C, like was this equation 28, times ACP, we found ACP square, ACP 280,000 square over PCP do 0. T crack, we found T crack just to do 0.2 kilo Newton meter. أقعد لي بالنيوتن مليمتر درجة we get the result in Newton millimeter. Everything in this equation in Newton and millimeter. Therefore, we get the result Newton millimeter. We transfer to kilonewton meter divided by 10 to power 6. In moment divided by 10 to power 6. Now I check the section for torsion if it's required. Designed for torsion reinforcement or not? Section for torsion reinforcement. Designed for torsion reinforcement. Then phi T crack over 4. Here is over 4. Phi 0.75 also in torsion. T crack just to do 0.2 over 4. أو برقم أكاتشان أكاتا is equal to أكاتا يعني the point half. And TU is equal to Panjaudu. Then this is, if it is less than this, it's not required to design for torsion. This is more than this, then design for torsion reinforcement is needed. Design for torsion reinforcement is needed. design for torsion enforcement is needed. Now I go to check the section for shear. This section can resist shear, can resist torsion, apply torsion. بتشوك يا قولي لو بتشوك بيت قولي كيتوا زانين in the shear زانين check the section 4. This is 4 3 4. Now I go to check the section for shear. This is equal to 4. Check the section strength for shear. Sectional strength for shear. If phi Vs, if phi is Vs, stress intensity less than 0.66 F prime C BW, it's not required. If this is more than, if this is more than, a base section is small, therefore must be increase the section. I will less than is okay. Now I check this requirement for shear. I check this requirement for shear is equal to. Now I go to find. I use this equation. VC V ultimate is equal to phi Vs plus Vc. I try to find Vs. V ultimate, we have V ultimate 255.75. Vs unknown. Well, Vc is equal to Vc. We found Vc. Do صوت بس 202 to 9.4. The unknown dissection Vs, we found Vs. Then we found Vs is equal to 103.9 kilonewton. We found Vs. Vs mandozio صوت 0.9 kilonewton. Now I check Vs. I check with this equation 0.66 FC prime BWD. I check it 0.66 FC prime 28 BW 400 D. شصتو. So you have this value أكابا شان أكاتا هشصتو النوت 0.6 كيلو نيوتن. و VS أكاتا صتسي. إذن this is true. صتو سي 0.9 less than this. Then this the section is okay for shear. Then the section is okay for shear. Now I check the section for torsion, shear and torsion at the same time. 5. Check the section strength for shear and torsion. For shear and torsion at the same time. Equation درجة كذا كاردينا. شين بيوستا بICT أويا. إذن equation درجة كمان شيء أكاد I found x1. It's required to find x1. It's required to find x1. This distance, we call it y1. From center to center, this distance is equal to x1. x1 شيء كات totally 400. Totally 400. 400 minus cover chill. Covered at the system minus chill. Minus stirrups 10 over 2 at the left, or 10 over 2, I go to center of the stirrup, center of the stirrup to center of the stirrup, minus 10 over 2, and then this is equal to سياسة the milli. X1 is equal to سياسة the milli. Y1 is also the same idea. Chill, زائدا stirrups 5 over 2, أكاد شلو بينج, أكاد 45. Chill, زائدا die over 2, أكاد شلو بينج. We can directly use شلو بينج. تو مباشرة شلو بينج بكار إذا لنا حفصت minus شلو بينج ماينس شلو بينج شو هاتوا شل زائدا 5 over 2 كده يكا بينج شل زائدا 5 over 2 بوي شلو بينج دايركتلي تواني مباشرة بكاربيني سيكل شصتو دا ملي. I found x1 and y1. Now it's easy to find a or edge hoop area that's enclosed with stirrups, with the steel bar, with the stirrups. أكاتا كان أكاتا summation x1 y1 x1 شنا سيصتو دا y1 شصتو دا. إذن أي نوت edge أكوابا كان أي نوت edge أكاتا 1 سطو هشتاو 9000 وسط مليمتر سكوير. أي نوت ما بيوصل according to إيسا أكاتا 0.85 أي نوت H 0.85 أي نوت H يك هش نو سط is equal to 160 حفصة سيوبينج millimeters square. Now pH, I require pH perimeter hoops that's enclosed with the hoops. داخل بهoops enclosed with the hoops enclosed with stirrups hoops web reinforcement is equal to summation x1 plus y1. Here summation it is equal to what chan x1 سياسة دا y1 شصة دا سياسة دا شصة دا سياسة دا شصة دا times 2 أكاتا times 2 pH أكاتا شصة دا plus أكاتا هزارو أشتة ملي. Now I can use the equations. أتوانم equation كمان بكار longitudinal equation أتوانم بكاري بينهم أو equation درجنا كمان بوي برسيارك حلبكي the equations أكاتشي the equation كمان we can use this longitudinal equations. The ultimate over PW d square plus CU pH over 1.7 a closed perimeter square a not h square a not h square not h hooped totally enclosed with the hoops square must be phi less than phi VC over VWD plus 0.66 square root of FC prime. Now applied. Now I try to apply these equations. V ultimate, do satu panja, kilo, 10 to power 3. VW, 12 D is equal to, we found D firstly, shastatu. So you have square plus TU, panja do. This is moment, 10 to power 6, don't forget, everything transferred to Newton millimeters. Times pH, we found pH, Azaru, Ashtatu Chel, over 1.7, A naught H, 189,100. Square, total square, must be less than 0.75, for shear and torsion, like 0.75. VC2, we found VC2 to 9.10 to power 3 over VW, Charsat, over D, Shastatu Siuhav, plus 0.6628. F primes, I closed the bracket. We found the left side is equal to 1.854. Right is equal to, say, 0.328. This is strength, this is applied, this is strength, this is applied. Therefore, it's okay. Therefore, the section is okay to resist shear and torsion. The section is okay to resist, to applied shear and torsion. Now, I go to design Now I go to design for shear. Now I go to design for shear and torsion at the same time. I go to design for shear and torsion at the same time. Now design the section for shear and torsion. Design the section or beam for shear and torsion as transverse enforcement. Transverse enforcement. Torsion, transverse enforcement. Stirrups, transverse reinforcement. We have two designs for torsion. One of them transverse reinforcement stirrups, the other longitudinal reinforcement. We put longitudinal reinforcement also to resist torsion. Design for section for torsion. Equation for shear, AV over S is equal to VS over Fy transverse times D. And this is equal to, everything is noun, this equation VS is noun, VFYT, D is noun. أتوانم بيدوزمو VS, we found VS, we previously found VS, where's VS? This is VS, so to say point no, we found VS, so to say point no, times 10 to power 3 this kilo, Fy 420, D شصته سيحف is equal to 0.388 millimeter square per millimeter. This is per 2 legs. 2 legs. We have here 2 legs. Per 2 legs for sure. Per 2 legs. Now I go to design for torsion enforcement. This is from, it's required for shear. This is required for shear. Now for torsion. For torsion, we have this equation. Tn is equal to Tu is equal to pi Tn. Tu, we have Tu, Panjao 2. Well, 5.75, we can find Tn. We found Tn. Tn is equal to, just to know, 0.3 kilo Newton meter. Then the applied shear with standard reduction factor just 0.3. We must design the section for just 0.3 kilo, 69.3 kilonewton meters. We must design the section for torsion 69.3 kilonewton meters. Now I have this equation for transverse Tn is equal to 2 A naught AT over S Fy transverse cotan theta. Cotan theta. Now I put the noun term. The noun item here is noun where I put it 69.3 times to power 6. 2 A naught is noun. A naught is noun. 160. This is A naught. This is A naught. 160. 735. 80 over S is unknown. Fyt 420. Cotan 45 is 1. Cotan, we take 45 degree, the theta of the angle of cracks, we use 45 degree, and therefore is equal to 1. We use 1, 45 degree, we use 1. Now the unknown is this equation, just 80 over S. We found 80 over S is equal to 80 over S is equal to 0.708 millimeter square per millimeter. In torsion per, here in shear per 2 legs, here in torsion per 1 leg. 1 leg, just for 1 leg. For 1 leg. The torsion occur here, here, as we draw previously for the shear stress for torsion. Therefore, it's required here for 1 legs. Now, total torsion required, total chani piyasa total chani piyasa, then it's required stirrup chani stirrup piyasa in this way. In this way, is equal to 80 over S plus AV over S, and this is equal to this term, 80 over S We found 80 over S. 0.3, 0.07, 0.8 for torsion. We found for torsion or for torsional. زائدا for shear. This is for shear 0.388. This is for one leg. This is for two legs. This must be divided by 2. For one leg, for two, this must be divided by 2. We can for one leg bit. And then we found for shear and torsion at the same time is equal to, for shear and torsion for the same time is equal to, sorry, this number is wrong. I got a dosiment of 0.514 or 0.514. Here is equal to 0.514. 0.514 total is equal to 0.708 millimeter square per millimeter. I write per millimeter over S per one leg. Per one leg ويكفي per one leg إذا per one leg إذا استا أومان هي أمرق أومان هي شلون توين تحويلي كي بكين استيرابس اللي الرشا كما الرشا كما الرشا كما إذا شلون توين هو تحويل كم إذا أما بيلم 80 over S زائدا AV over 2S كرديشان وكويا أما بلي إكسانا أما ناوينين A TV VT هذا تمام VT over S أو هاي بيلين أما هاي إكسانا بتشان إكسانا 0.708 وكو بيشان استيراب ما شنا استيراب in the hour beam stirrup كمان شنا this is stirrups. If we use phi 10 millimeters 10 millimeters إذا AV for shear and torsion here for shear and torsion إذا AVT is equal to half tau هشت مليم for phi 10 noun is noun S is unknown what total required is noun 0.708 is noun. The only unknown half tau this AVT for titan equivalent AV فرقناك for stirrups even S is now known as we found S is unknown we found S 111 millimeters center to center for stirrups distance between stirrups and the adjacent stirrups stirrup like stirrup كي تنشتي صوتي ينظم this according to the applied loads again according to the minimum requirement we know minimum requirement AT over S plus AV over 2S must be greater than or equal to we have two equations 0.35 BW over FYT over FYT أما أكسانا 0.35 BW شارصت BW this BW بواب FYT is known شارصت بيست إذن here is equal to must be greater than or equal to greater point equivalent at least equal 0.333 millimeter square per millimeter or certainly for one legs. Then AVT with my this term is equal to AVT. This term we say over S. At I have seen AVT over S. Well, AVT is half tawashed for 510 millimeter half tawashed. Then S is unknown. S minus 0 maximum S according to this equation do to CU milli. Also, we have second equation here, AT over S plus AV over 2S must be greater than or equal to 0.062 FC prime BW over FYT. Substitute here, تمشاك in درجة 0.3 0.312. Substitute here 0.312. إذا AVT over S يكسانا 0.312. إذا maximum S شنكات يكسانا وشن maximum S maximum شنكات أجر هم هفتاوش به for 5-10 ملم هفتاوش به S يكسانا 250 ملم. We have another requirement. S max maximum S must be less than pH over 8. pH, we know pH. Where is pH? This is pH. This is pH. This is pH. This is pH. هزار وشطوشل over 8. هزار وشطوشل over 8. مشون سيمانا. Okay. أكاتا صبسي. مليم. Now we found this distance. This is from the loads. This is from minimum requirement. Then we use the less value. Then S from is equal to 111 millim, center to center. Then this is control. Or governing control or the governing. We use 5-10 millimeter stirrup adds. Use stirrups. Stirrups 5-10 with adds 111. We can use 111. It's better in practical point of view. ناحية عملي we use 100 millimeter center to center. 100 millimeter center to center. We design the stirrups or transverse reinforcement for this type applied shear and torsion. Now I go to design for longitudinal reinforcement. For longitudinal reinforcement. Now I go to design for longitudinal reinforcement. This is point number 6, point number 7. Design for longitudinal reinforcement due to applied torsion. Due to applied torsion. Then we have this equation, applied torsion. We have this equation in applied torsion. Tn is equal to T2 I naught AL, small al, over pH, times Fy tan theta. Here is tan theta, here is cotan theta. The equation of Tn here is cotan theta. Here is Fy transverse stirrups, here is Fy longitudinal reinforcement. Here is similar, equal, same, but the actual value is this. Tn, we know Tn, just no points here, 69.3, we know Tn, times 10 to the power 6. 2, I naught, we know is also I naught, 160, half status pH, this I naught, times Al, and now pH is now 140, 1840 times Fy, short status times Fy, short status times tan theta is equal to 1. Tan 45, we use theta angle of cracks. We say we use 45 degree for calculation. Therefore, we found here AL is equal to نوصته شلو page millimeter square. AL, we put AL reinforcement here for longitudinal reinforcement, for torsion. This is coming from the load. Now we have also AL minimum. We have two equations for AL minimum. Two equations. AL minimum is equal to equation 0.42. Substitute FC prime ICP over FY transverse minus IT over S PH times FY transverse over FY. We have two equations. I use this equation 0.42. Substitute this section 28. ACP, we found ACP. Do 80000 FY transfer to this 420 minus 80 over S now. 80 over S now. 80 over S. Where's this 80 over S? 0.514 times pH 140. FY is similar, 1 over 1 similar times 1 over 1. We can find a minimum. This is minimum. This minimum AL minimum requirement must be more than this. I got 537 millimeter square. This is less than this. The other equation we can substitute the other equation also. We have the same equation except here 0.175 times BW over 420. It is the same equation minus similar except here 0.175 except this term times BW 400 BW. This is BW over FY transfer to this 420. The other is similar. Is an AL minimum. The second equation for AL minimum is equal to 1175 millimeter square. Now we get two values, this value and this value. I take the minimum AL. Now minimum AL, we use the less value. Here we use, according to the ACI, we use the less value. Equal to piansato C1 millimeter square. Now from the load, minimum piansato C1 from the load 945. Minimum 537. Then now use AL is equal to 945 millimeter square. 945 millimeter square. 945 millimeter square. Ista 945 أبي دابش كنا سر سكشنا كمان. أبي لا سر سكشنا كمان دابش كن. يك 2 سر. دابش كن. Now this must be distributed. I divide it here. I'm going to come in 3 layers. Do 3 layers. 1, 2, 3. Top bars, bottom bars, medium, mid height bars, bottom bars. Then 9, 4, 5 divided by 3. 9, 4, 5 divided by 3 is equal to siyasatu panza millimeter square. Now add the siyasatu panza 3150 at top. 3150 at bottom. I added زيادة كم to this reinforcement زيادة كم حدود وانزة زائدا أول شيء زيادة كم واللير بينج بس بينج أول زيادة كم وآت ميت هاي زيادة كم آت ميت هاي زيادة كم شلون زيادة كين in this way شلون زيادة كين in this way ألين للثروة at top للثروة at top at top شيء كات we have 2 512 512 يعني 113 millimeter square plus it's added, this is added due to torsion, this is added due to bending, due to any reason, due to bending for example, but here we have also this is due to torsion. إذا totally كانك at top. This is must be provided at top. Totally at top must be provided 541 millimeter square must be provided at top. If we use اگر شانزەی بەکاربێنین ئەگەر بکەینە شانزەی إذا divide by 200 چەند باڕەکە divide by 200 إذا therefore we use 3 5 16 millimeter at 5 16 millimeter at top here 3 5 16 millimeters instead of 2 to 5 12 we use if we added the effect of torsion زیاد کرد it be say 5 شانزە. Now at the bottom at mid height يعني era mid height أميرة mid height أبي چند زیاد کم we have 315 چند باشه 315 at mid height we have 3 pounds چند باشه بکار بیم 200 we use 2 5 16 millimeter at mid height. This is 2 5 16 millimeter at mid height according to the 315. Now at bottom we have 5 stupends. We have 5 stupends. 5 times 400 نواة زائدا 600 pounds. زائدا this is all due to torsion. This is due to bending. This is due to torsion, and this is equal to 2765 مليمتر سكر. باشا 2765 مليمتر سكر. Now 2765 مليمتر سكر divided by 5 is to pinch. 5 is 25 divided by 525 400 akata chan for this is 525 this is equal to chan 6 is 5 is to pinch millimeter at bottom. Even at bottom we use 6 1 2 3 4 5 I use 6 5 25 millimeters at bottom. This is we take the effect of torsion also. Now it's required to find this distance. This distance we call the S1. S1 must be less than 300 millimeters. Must be less than 300 millimeters. I found S1. Check the spacing. Check the spacing between longitudinal bars. Longitudinal bars. I check the distance. Akachan, I check the distance. Akata S1 is equal to this distance 700 minus cover at top 2 times chill plus 10 stirrups minus 12 over 2 here's 12 16 over 2 we say 16 over 2 minus 25 over 2 the distance one space therefore divide by 2 space is equal to chan is equal to siyasatu the million. This is more than 300 according to the specification is not allowed. This must be less than 300 according to the ACI codes. This is not satisfied. Therefore what we do now now I try to the section Now I try to divide the section in more than 3 layers. The up layers, still we have 3, 5, 16 millimeters. At bottom, we design for bottom 6, 5, 25 millimeters. But here we must divide this distance into 3 spaces instead of S1, instead of 1 space. We must divide it by 3 spaces instead of 1 space. And then therefore S1 divided by 1, 3. The same formula here. The same. Divide by 1, 3. 1 space, 2, 3 space. 1, 2, 3 space. Here is equal to 193 millimeters. Well, this is less than 3 millimeters. Even this is okay. Even this is okay. This is equal. This is not okay. 2 spacing is not okay. This is 4 spacing. Here it's required mid height. Mid height requires 315 millimeters square. Therefore, I revise the calculation here. Calculation revised. 315 I divided by, this is 516. I divide by 512. 113. It's equal 4, 5, 12 here. This is equal to 4, 5, 12 millimeters here is required. 4, 5, 12 millimeters here is required. This is the reinforcement details. Stirrups spacing 5. Stirrup spacing 5, 10 millimeter at 100 millimeter center to center. 100 we design for longitudinal reinforcement, for stirrups. For stirrups, this is 100 millimeters. This is 100, and this is the detail of the reinforcement. واضحة. Now, lastly, I check the diameter of the stirrups. Diameter of the stirrup must be at least 10 millimeters for torsion, or 0.0425 times spacing between the stirrups 100, and this is equal to 4.7 millimeters. Even this control, even okay. I check the diameter of the stirrups. This is the check for the diameter of the stirrup must be greater of one of these two values, larger of one of these two values.